For our lesson, we're going to target the following. First one, plotting points in a Cartesian plane and finding its quadrant, identifying the solution of the given linear equation, finding slope in a given linear equation, finding slope in a given graph, and lastly, finding slope in a given 2 points. Let us have the first lesson, which is all about plotting points in a Cartesian plane and finding its quadrant. Using this, or what we call the Cartesian plane, we have here the horizontal number line that is also known as the x-axis, the abscissa, and we also have the y-axis, or the vertical line also known as the ordinate. The intersection between the x-axis and the y-axis will be what we call the origin, which has the ordered pair of 0 and 0. Given this, we could have the four section of the Cartesian plane. We have here along the positive x and along the positive y, also known as the quadrant 1, and we also have along the negative x and along the positive y, also known as the quadrant 2, and we also have along the negative x and along the negative y, also known as the quadrant 3. And lastly, we also have along the positive x and along the negative y, also known as the quadrant 4. Given this, let us try to find out where will be the following points is located in the Cartesian plane. Let us have the first one, 3 and 4, which is along the positive x and along the positive y. So therefore, it is located in the quadrant 1. For the next one, we have negative 2 and negative 5. It is along the negative x and along the negative y. So therefore, it is located in the quadrant 3. We have along the negative x and along the positive y. So therefore, it is located in the quadrant 2. For the next one, we have 4 and negative 1. It is located along the positive x and along the negative y. So therefore, it is located in the quadrant 4. And for the next one, 0 and negative 3, our x is 0 and our y is negative 3, which is along the negative y. So therefore, the point is located along the y-axis, also known as the ordinate. And for the last one, we have 4 and 0, wherein we have x that is 4, that is along the positive x, and we have y that is 0. So therefore, the point is located along the x-axis, also known as the abscissa. Now let us try to plot the points in the Cartesian plane. We have here 3 and 4. First one, let us try to locate the points in our number line. We have here 3 that is located in the positive x-axis, and we have 4 that is located in the positive y-axis, and the intersection of it will be the location of the point. So therefore, the point is located here, and let us label it as 3 and 4. For the next one, we have negative 2 and negative 5. Negative 2 is located in the negative x-axis, and negative 5 is located in the negative y-axis, and the intersection of those points will be the location of the point. And let us call it as negative 2 and negative 5. For the next one, we have negative 1 that is along the negative x, and we have 2 that is along the positive y, and the intersection of this will be the location of the point. So therefore, let us call it as negative 1 and 2. For the next one, we have 4 and negative 1. 4 that is located along the positive x-axis, and negative 1 that is along the negative x-axis, and the intersection of those points will be the location of the point. And let us call it as 4 and negative 1. For the next one, we have 0 and negative 3. We have here 0 as the x-axis, and we have here negative 3 that is located in the negative y-axis, and the intersection of this is exactly in the negative 3 along the y-axis. So therefore, let us call it as 0 and negative 3. For the last one, we have here 4 that is located along the positive x-axis, and we have here 0 that is the y-axis. And the intersection of this will be exactly the positive 4 that is along the positive x-axis. And let us call it as 4 and 0. Now, given this point in a Cartesian plane, pause this video and identify the location of the point in the Cartesian plane and plot it. Now let us try to find out. We have here in the Cartesian plane negative 3 and 1, wherein 1 is located along the positive y-axis and negative 3 is located along the negative x-axis. So therefore, the point is located along the quadrant 2. We have here 5 and negative 3, wherein 5 is located along the positive x-axis, and we have negative 3 that is located in the negative y-axis, so therefore the point is located along the quadrant 4. For the next one, we have negative 4 that is located in the negative x-axis, negative 5 that is located in the negative y-axis, so therefore the point is located along the quadrant 3. For the next one, we have 2 and 4. 2 that is located along the positive x-axis and 4 that is located along the positive y-axis, so therefore the point is located along the quadrant 1. For the next one, we have 0 and 5, wherein x is equal to 0. We have here y that is equal to 5, which is located along the positive y-axis. So therefore, the point is located along the y-axis, or also known as the ordinate. For the last one, we have negative 6 and 0, wherein we have negative 6 as the x that is located in the negative x-axis, and we have y that is equivalent to 0. So therefore, the point is along the x-axis, or also known as the abscissa. Now let us try to plot the points. Let us have negative 3 and 1, wherein negative 3 is located in the negative x-axis and 1 that is located along positive y-axis. Therefore, the intersection of the point will be the location of it. So let us call it as negative 3 and 1. Let us have the next one, 5 and negative 3. 5 that is located along the x-axis and negative 3 that is located along the negative y-axis. And the intersection of the point will be the location of it, and let us call it as 5 and negative 3. Now let us have the next one, negative 4 and negative 5. Negative 4 that is located along the negative x-axis, and we have negative 5 that is located along the negative y-axis, and the intersection of the point will be the location of it, and let us call it as negative 4 and negative 5. Let us have the next one, 2 and 4. 2 that is located along the positive x-axis and 4 that is located along the positive y-axis, and the intersection of this will be the location of the point, and let us call it as 2 and 4. For the next one, 0 and 5, we have 0 as our x-axis and we have y that is equal to 5, which is located along the positive y-axis, and the intersection of the point will exactly be the point along the y-axis, which is the positive 5. And let us call it as 0 and 5. For the last one, we have negative 6 and 0. Negative 6 that is located along the negative x-axis, and we have here 0 that is in the y-axis, and the intersection of the point will be exactly in the negative 6, which is located in the negative x-axis, and let us call it as negative 6 and 0. Now let us have the next lesson, which is all about identifying the solution of the given linear equation. When in terms of finding the solution, it is the ordered pairs that lies in the linear equation. Given the line, all the points that can be found along the line is considered the solution. Now let us try to find it in a given linear equation. Suppose that we have 4x plus 2y negative 4 is equal to 0. Let us try to find out if 4 and negative 6, 1 and 2 are the solution of this linear equation. Let us have the first one, 4 and negative 6. In order to find the solution, what are we going to do is we're just going to substitute the value of x and y in the given linear equation. We have here x that is equal to 4 and we have y that is equal to negative 6. Let us try to substitute it in our linear equation. We have here 4x that will become 4 times 4 plus 2y that will become 2 times negative 6 minus 4 equal to 0. Let's now simplify. 4 times 4 that is equivalent to 16 plus 2 times negative 6 that is equivalent to negative 12 minus 4 is equal to 0. Then after that, 16 plus negative 12 is equivalent to 4 minus 4 is equal to 0. So we have 4 minus 4 that is equivalent to 0, that is equal to 0. So as you can see, it is true that 0 is equal to 0. Therefore, we could say that 4 and negative 6 is the solution of our linear equation. Let us try to find out the next one, which is 1 and 2, wherein x is equivalent to 1 and y is equivalent to 2. Let us try to substitute. 4x will become 4 times 1 plus 2y will become 2 times 2 minus 4 is equal to 0. So we have 4 times 1 that is equivalent to 4 plus 2 times 2 that is equivalent also to 4 minus 4 is equal to 0. We have 4 plus 4 that is equivalent to 8 minus 4 is equal to 0. So we have 8 minus 4 that is equivalent to 4 equal to 0. So as you can see here, 4 is not equal to 0. So therefore, 1 and 2 is not a solution of our linear equation. Now, given this linear equation, 5x plus 3y plus 6 is equal to 0, find if negative 2 and 5, negative 3 and 3 is the solution of this linear equation. Pause this video and try to answer this. Let us start first with negative 2 and 5. Given that x is equivalent to negative 2 and y that is equivalent to 5, let us try to substitute. 5x will become 5 times negative 2 plus 3y will become 3 times 5 plus 6 is equal to 0. 5 times negative 2 will become negative 10 plus 3 times 5 will become 15 plus 6 is equal to 0. Negative 10 plus 15 will become 5 plus 6 is equal to 0. 5 plus 6 will become 11 is equal to 0. So as you can see, 11 is not equal to 0. So therefore, negative 2 and 5 is not a solution of our linear equation. Now let us try to have negative 3 and 3, wherein x is equivalent to negative 3 and a y that is equivalent to 3. Let us try to substitute. 5x will become 5 times negative 3 plus 3y will become 3 times 3 plus 6 is equal to 0. 5 times negative 3 will become negative 15 plus 3 times 3 that will become 9 plus 6 is equal to 0. Negative 15 plus 9 will become negative 6 plus 6 is equal to 0. So we have negative 6 plus 6, the answer is 0, is equal to 0. So as you can see, 0 is equal to 0. So therefore, negative 3 and 3 is a solution of our linear equation. Let us have the next lesson, which is all about finding slope in a given linear equation. In a given Cartesian plane, slope is considered the steepness of the line or how the line is being inclined. Given the linear equation in a standard form that is equivalent to ax plus by plus c is equal to 0, in order to find the slope, what are we going to do is we're just going to change it to a slope-intercept form, wherein it will become y is equal to mx plus b, wherein m is the slope of a given line. Let us have an example. 5x plus 3y plus 2 is equal to 0. Let us change it into slope-intercept form. To change this, what are we going to do? All the other terms aside from the variable y will be moved on the right side of the equation. So we have here positive 2. In order to move it to the right, what are we going to do is we're going to add it to its inverse. The inverse of positive 2 is negative 2. So if we add negative 2 on the left side, we're going to add negative 2 on the right side. So we are going to cancel 2 and negative 2 since it will become 0. So therefore, from the left side, we will have 5x plus 3y that is equal to 0 plus negative 2, that the answer will be negative 2. Then after that, we have here 5x. To move 5x to the right side of the equation, what are we going to do is we're going to add it to its inverse. So we have 5x that has the inverse of negative 5x. So if we are going to add negative 5x in the left side, we're going to add negative 5x on the right side. So we're going to cancel out 5x plus negative 5x. That is because it will become 0. So therefore, from the left side, we will have 3y is equal to negative 2 plus negative 5x. Since they are not like terms, therefore the equation will be negative 5x minus 2. From that, given the equation 3y is equal to negative 5x minus 2, remove the numerical coefficient of variable y. Given that the coefficient of variable y, which is 3, in order to remove the numerical coefficient of the variable y, we're going to multiply the whole equation to the multiplicative inverse of the coefficient of 3. So the multiplicative inverse of 3, that is equivalent to 1/3. To simplify the equation, it will become 1/3 times 3y is equal to 1/3 times negative 5x minus 1/3 times 2. So let us try to simplify. We are going to cancel out 3 since it will become 1. So therefore, we will have y is equal to 1/3 times negative 5x is equivalent to negative 5 over 3x minus 1/3 times 2. The answer is 2/3. So here, we already have the slope-intercept form in a form of y is equal to mx plus b, wherein the m is negative 5 over 3, and we have b that is equivalent to negative 2/3. Given that, we need, so here we're going to find the m. So here we're just going to find the m, which is the slope, which is here that is equivalent to negative 5 over 3. So the slope of the given linear equation is negative 5 over 3. Now, find the slope in the given linear equation. Negative 5x plus 1 over 5y minus 8 is equal to 0. Kindly pause this video and try to answer this. Let us try to find out. We have here negative 5x plus 1 over 5y minus 8 is equal to 0. Now, all the other terms aside from the variable y will be moved on the right side of the equation. We have here negative 8. In order to move on the right side of the equation, we're going to add it on the additive inverse of negative 8, which is equivalent to positive 8. So if we're going to add positive 8 on the left side, we're going to add positive 8 on the right side. We're going to cancel out negative 8 plus 8 since it will become 0. So therefore, on the left side, we still have negative 5x plus 1 over 5 y is equal to 0 plus 8, that is equivalent to positive 8. So we have here negative 5x. In order to move it on the right side of the equation, we're going to add it to its additive inverse, which is equivalent to positive 5x. And since we add positive 5x on the left side, we're going to add positive 5x on the right side. So we're going to cancel out negative 5x plus 5x since it will become 0. So therefore, we will have 1 over 5y is equal to negative 5x plus 8. Since negative 5x and 8 are not like terms, therefore, we're going to write the equation as 5x plus 8. Then after that, given the equation, 1 over 5y is equal to 5x plus 8. Remove the numerical coefficient of the variable y. Given the numerical coefficient, which is 1 over 5, in order to remove, we're going to multiply the whole equation to the multiplicative inverse of the numerical value. So the multiplicative inverse of 1 over 5 is equivalent to 5. So let us try to simplify the equation. So we have 5 times 1 over 5y is equal to 5 times 5x plus 5 times 8. Let us try to simplify. 5 times 1 over 5 will become 1, so therefore, we will have y on the left side is equal to 5 times 5x, the answer will be 25x plus 5 times 8, the answer is 40. So in our given equation, it is now in a form of slope-intercept form, which is y is equal to mx plus b, wherein m is equivalent to 25 and b that is equivalent to positive 40. Given this, the slope, which is the m, is equivalent to 25. Therefore, the slope of the given equation will be 25. Now let us have the next lesson, which is all about finding slope in a given graph. Given the Cartesian plane and a line inside the Cartesian plane, let us try to find the slope of this given line. So here, what are we going to do is we're going to find 2 points on the Cartesian plane. Then after that, what are we going to do? Simply, we're just going to remember the rise over the run. We're going to count the rise and we're going to count the run from the given 2 points. The rise will be 1, 2, 3, 4, and 5. So we have here rise that is equivalent to 5. And we have here the run. To the right side, we will have 1, 2, 3, 4, 5, 6, 7. Since the run is moved to the right, so therefore the run will become positive 7. Given this, the slope will become 5, which is the rise, and 7, which is the run. Now let us try to identify the slope in a given graph. Given this line, kindly pause this video and try to find the slope given that we have here the 2 points. Now, given the Cartesian plane and a line and a given 2 points, let us try to find out rise over the run. Let us count the rise, which is 1, 2, 3, 4, 5, and 6. Wherein rise is equivalent to 6. And for the run, we have 1, 2, 3, 4, 5, 6, and 7. So we have here the run, which is 7, and since it is going to the left, therefore we will have the run that is equal to negative 7. For the slope now, we have 6, that is the rise. We have here negative 7 as the run. So therefore the slope will become negative 6 over 7. Now let us have the last lesson, which is finding the slope in a given 2 points. Given the 2 points, 3, 5, and 4, and 7, use the formula y sub 2 minus y sub 1 all over x sub 2 minus x sub 1 in order to find the slope of the given line. Now, given the 2 points, 3, 5, which is the point 1, and we have 4, 7, which is the point 2, what are we going to do is we're just going to label those points. We have here the x sub 1, which is the 3, and we have y sub 1, which is the 5. That is because it is in the point 1. We have x sub 2, that is the 4, and we have y sub 2, that is 7. That is because it is the point 2. Given this, let us try to substitute it on our formula. So we have the slope, which is equivalent to y sub 2, that is equivalent to 7, minus y sub 1, that is equivalent to 5, all over x sub 2, that is equivalent to 4, minus x sub 1, that is equivalent to 3. Let us try to simplify. 7 minus 5, the answer is 2. All over 4 minus 3, the answer is 1. So therefore, the slope will become 2 over 1 or 2. Now, identify the slope between the 2 points. 5, negative 7, and negative 2, 4. Kindly pause this video and try to answer this. Given these 2 points, 5 and negative 7, negative 2 and 4, using the formula, let us try to find the slope. We have 5 and negative 7, which is the point 1. We have negative 2 and 4, which is the point 2. So therefore, x sub 1 is equivalent to 5, y sub 1 is equivalent to negative 7, x sub 2 that is equivalent to negative 2, and y sub 2 that is equivalent to 4. Given the formula, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. We have here the slope, wherein y sub 2 that is equivalent to 4 minus y sub 1 that is equivalent to negative 7 all over x sub 2 that is equivalent to negative 2 minus x sub 1 that is equivalent to 5. So let us try to simplify. So here we're going to use the rule in subtracting integers, wherein the second number will change its sign. So we have negative 7 that will become positive 7. Then we're going to proceed to addition. And let us copy the first number, which is 4. All over, we have here 5 that will become negative 5, and proceed to addition and copy the first number, which is negative 2. So we will have 4 plus 7 that is equivalent to 11 all over negative 2 plus negative 5. The answer is negative 7. So the slope of the line will become negative 11 over 7. Thank you for answering the practice task in the Math Legend. See you on the next lesson.